Good morning. As introduced, I'm Andy Swafinga. I work for the Agricultural Research Council. I'm based in the Eastern Cape province of South Africa in a small town called Grahamstown. And today I'm presenting part of the results for my MSc students' work on assessing the effects of herding on livestock grazing patterns in the Amakuzeni communal rangelands using GPS trackers. As I've mentioned, I'm from the Eastern Cape. Eastern Cape, which is made up of former homelands. There are two actually homelands called the Transkei and the Ciskei, but now they've all been amalgamated and we are the Eastern Cape. So the Eastern Cape has a long history of economic neglect and is mostly rural. And the ability of rural people to make a living is linked to their agricultural practice, especially livestock farming. And livestock has been identified as a key commodity for human well-being because it provides benefits such as food, income, nutrients, employment, traction, and others. However, its sustainability really depends on well-managed rangelands. But in where the study is based in the former Ciskei, in most rural areas, in fact, in the Eastern Cape, management of the communal rangelands is on a collective basis and they are mostly open access, meaning that there's no boundary fence around them. So one village can be hosting animals from a number of villages because there's no boundary, and also there are no management strategies. So each household does what they feel is best in terms of managing their livestock, but the resource that they use is the same. And as a result, most communal rangelands in the Eastern Cape and other parts of South Africa have been described as severely degraded. And the degradation is attributed to many factors, some of which I've mentioned, and also, or mostly, the absence of the livestock and rangeland management strategy. And as a result, most communal areas apply, it's not really a management strategy, but there's an unregulated continuous grazing that happens, where animals are just led to the grazing in the mornings and left there to graze the whole day wherever they please. And sometimes they're collected or they come back on their own in the evenings or late afternoons. And which means that then they can graze wherever, which can promote selective grazing, where animals would only graze preferred species, putting those species mostly decreases and other high nutritional species at risk of disappearing from the system as they are grazed the most, and then giving an opportunity to unpalatable or more unpalatable grasses to dominate those grazing areas. Hence, there is a need to explore a rangeland management strategy that will promote an optimal utilization of the communal rangelands. So the study was aimed at assessing the impact of herding on livestock grazing patterns using livestock GPS trackers. And as I've mentioned, this was something that we were trying out because there's no herding happening in the villages. And so we wanted to firstly establish grazing patterns of the herded and the free-ranging animals. So there were herded animals, and then there were those that were left to graze as usual. And also to determine the herbaceous species composition within frequently grazed spots from the grazing for both the herded and the free-ranging animals. And this is the study site. As I've mentioned, we are in the Eastern Cape province, And the study site is in the Amatole district municipality and under the Nkongobe local municipality. And that is where it is located, in the Nkongobe municipality, close to a place called Hawksbeck, which is a nice place surrounded by mountains, but it's just a village that is just, a short distance from there. So the Amakuzeni is made up of 3 sub-villages, which is Guquka, Gilton, and Sombondo. And this area, which is not just the Amakuzeni area now, but the Alice area where the study site is, receives about 450 to 600 millimeters of rainfall annually, with average temperatures of 19 degrees Celsius in winter and 28 degrees Celsius in summer. And the vegetation types in the area is the Amatole Mountain Grassland, Bishopthorn Veld, and the Eastern Cape Escarpment Thicket. So you can already see the diversity. These fall within 3 different biomes. So the methods that we applied is we had selected 10 households from the 3 different, across the 3 different sub-villages. The selection was based purely on willingness to have the collars fitted on the animals. And we had 10 collars, so we had 1 collar per household. So we just chose 1 animal that would represent the head. But the other part of the study is we also weighed 5 animals from each of those households so that we could see the impact, but that is not reported in this presentation. But we had 5 households that would head the animals and 5 households that would just continue as usual to just lead their animals to the grazing and let them graze the whole day, and others that were going to, for the first time, engage in heading. So the data then, or the trackers, who remained on the animals for a period of 8 weeks. And then when we took them off, we downloaded the data, because the trackers themselves are catalog trackers. So we downloaded the data using a catalog software, stored them in comma-delimited ASCII text format, and as well as Google Earth KML files. And this is what the data would come looking like when we've downloaded it, giving you the date, the time, longitude and latitude, which are the points where the animals have spent the time, the altitude, the satellite from which the data was retrieved from, as well as the speed. And then the Google Earth images will come looking like that. And then in establishing the grazing patterns, the KML files were displayed on Google Earth Pro, where a series of points represented the livestock grazing patterns. And then these GPS points were used to create density maps in ArcGIS 10.2, indicating where the animals had spent most of their time, which we had referred to as frequently grazed spots, because it means that those are their preferred spots. And then we digitized those preferred spots, and on those preferred spots we did a survey on them to check which plants were found, specifically grasses. So we used a point-to-turf method to determine the herbaceous plant species composition on those areas, whereby we laid 3 100-meter line transects up the slope, and then the nearest rooted perennial herbaceous plants were sampled at 1 meter intervals. And then grasses and karoo bush species were grouped according to their frequency of occurrence and their grazing statuses, which is as decreases, increases, or 1, 2, or 3. And these are the results. And this is just now showing where the animals spent their time based on the different, whether they were headed or they were free ranging. So the yellow orange color represents, I don't know how to operate this. Okay. So the yellow represents the free ranging animals, and the green represents all the headed animals. And then the red polygons, they represent the arable and the communal or the residential areas. So you can see from this that the animals spend time mostly around the arable areas and mostly around the households or the homesteads. And then there were a few that actually spent time on the grazing. That is for both the free range and the headed animals. And this is just to show the density maps. This is where we digitized the grazing spots. The bright blue represents areas that had the most points, which means that those were places where the animals spent most of their time, either grazing, because our GPS trackers cannot tell whether the animals were grazing or just lying there. And then this is the herbaceous results for the headed animals and for the animals that were free range. We can see these are all the grazing spots that we could digitize. And for the headed animals, the most dominant species that were found in the grazing spots was the Eragrostis plana, the Cynodon dactylon, and the Themida triandra. And for the non-headed animals, it was the most dominant was the Cynodon dactylon, followed by the Eragrostis plana, and the Sporobolus africanus, which is an increaser tree, which is very an unpalatable grass. And so the results showed that the grazing patterns of both the headed and free-ranging cattle were focused on areas close to the homesteads, arable fields, and foothills. And this is consistent with the optimal forage theory that states that animals attempt to make the best of foraging scenario by trading off cost against benefit. So since these animals were dependent on themselves to choose where to go, they would chose rather the areas that were closer to the homesteads. And in other cases, it is the owners who allowed them to graze closer to the homesteads, fearing that they would be stolen. And only cattle from 3 households in Gilton were shown to have grazed up the slope. And none of the animals went further up the mountains where good grazing was perceived to be in abundance. And as I've mentioned, grazing animals closer to the homesteads in other cases, especially for those that were free-ranging, people fear stock theft because, and also it's mostly older people who own animal in these villages. And while for headed livestock, we could say that the lack of herding knowledge from the herders, since they are used to unregulated grazing, could have been a reason why we did not see any difference in terms of where they were taking the animals. And in terms of the herbaceous, the species we found the 22 frequently grazed areas, and then these were the areas that we sampled for the herbaceous species. And a total of 16 species were encountered from all the grazing spots from the 3 different sub-villages, whether headed or free-ranging. and the most dominant for all of them, the overall dominant plants were Eragrostis planus, Cynodon dactylon, and Tetraenra. And the types of species encountered in the areas frequently grazed by herded and free-ranging animals did not differ, as I've mentioned, and this could indicate that, be an indicator of long-term grazing pressure on the animals, on the area. Both the herded and free-ranging animals frequently visited during the 8-week period they had the collars on. And owing to these factors, it can be deduced that in this case, herding did not influence livestock grazing patterns in all 3 sub-villages, which means that maybe a longer period is required for us to have the collars on in order to see the impact.
Thank you. Skip this finger around. Moderators, so you feel free to hang around and ask questions, maybe a little bit later on, just due to the time limit this morning. Is it very warm in here? No. Okay. It is very warm. I got a text that it's hot in here. All right, very good. Thank you. Thank you. Okay. You're up.
Okay. It's me again. I am going to introduce our next speaker. She's Natasha Grimmel. Natasha Grimmel is from Germany, from the University of Göttingen, and she's a PhD. She's a PhD student, and she will present to us her study on rotational stocking with rotational stocking with virtual fences, effects on grassland diet, digestibility, livestock performance, and stress levels of heifers.
Yes. Hello, everybody. Welcome. My name's Natasha. Where do I start? Well, this is my first presentation in front of a live audience. I'm a PhD child of COVID. I started in 2020, just after in between the first and second lockdown in Germany. So don't mind my trembling, it's just because I'm terrified. As I was correctly introduced, I'm gonna tell you today about some of the findings from my PhD. My PhD is on innovative technologies for sustainable livestock production systems. It's part of a large project in Germany called the Green Grass Project that was funded by the German Ministry of Education and Research. And the goal of this project is to find innovative technologies to foster pasture-based production systems. And I'm going to show you some of the findings from our most recent virtual fencing trial that we did with rotational stock pastures. So I want to start with a short introduction to virtual fencing. We've heard it a couple of times by now, but it is still a new concept. And essentially what a virtual fence means is replacing a physical boundary of a traditional fence with an invisible acoustic boundary that's defined by GPS coordinates. In our trial, we used the no-fence grazing technology that essentially, instead of putting up that physical fence, you're putting these collars onto the animal. These collars communicate via the cellular network with a smartphone app and a backend database. So what you'll do is in your smartphone, you'll draw the pasture, define whatever shape, size, form you like, and you add the collar to that pasture. And once the collar is physically located via GPS inside that pasture, the virtual fence goes up. What that means is that when the animal crosses the virtual boundary that you defined, the collar will emit an acoustic signal. If the animal returns back into the pasture, that signal will stop. If the animal continues outside of that pasture, the signal increases in pitch until at the highest pitch it emits the electric pulse. After a training where the animals learn to associate that audio cue with the electrical pulse, the system awards full control and predictability to the animal, whether or not that electric pulse is actually emitted. And you can change the pasture and redefine it in whatever way you'd like. So this is still, as I said, a very new concept, so there's a lot of reservation towards virtual fencing still, especially in countries like Germany, Switzerland, and Austria, where electric dog collars that emit electric pulses directly to the animal are illegal. So in investigating the potential for virtual fencing for livestock production systems, its effects on animal welfare is always a very vital part of that research. In our trial, as I said, we investigated the suitability of virtual fencing for rotational stocking systems. And we assumed the worst, right? We thought that it's not going to be useful for rotational stocking. It's going to increase animals' stress levels. It's going to decrease animal welfare because animals are going to be confused with frequent changes. They're not going to have a visible boundary. How are they going to understand? So we're going to have negative effects on animal stress levels. We're going to have lower animal performance, and we're going to expect a lower herbage digestibility just because our animals are more stressed. So what we did is we set up a trial in 2021 with 32 beef heifers that we divided into 4 groups. We had 2 subsequent grazing periods in which we compared virtual to physical fences. Each group consisted of 8 animals, and we put them into 2-hectare pastures each that were surrounded by an electric wire fence, very traditional. These pastures were subdivided into 4 paddocks each. And for the physical fence groups, these 4 paddocks were fenced with a traditional electric wire fence as well. For the virtual fence groups, the paddocks were subdivided with a virtual fence, leaving the animals to 2 virtual fence lines and 2 outside virtual fence lines that were supported by the electric wire fence. The animals grazed for 3 to 4 days in each paddocks and then rotated to the next from A, B, C to D. And what we did is we measured live weight before the grazing and after grazing of each period. We took fecal samples to measure fecal nitrogen concentrations for organic matter digestibility and fecal cortisol metabolite concentrations. And we took vegetation samples to measure in vitro organic matter digestibility by hand plucking samples mimicking what the cattle eats as well. The fecal cortisol metabolite concentrations reflect cortisol excretion in the animal 12 hours prior to sampling. So they give us an indication of how stressed the animal was 12 hours before. So we took the samples in strategic days, like after we rotated the animals before the grazing trial to have a baseline and such. And what we found is that there's no significant effect of the fencing system on fecal cortisol metabolites. What we did find was that the levels were higher compared to the trial we did in 2020 with continuously stocked pastures. And that's probably just because the animals in this rotational grazing study were exposed to more handling. They were exposed to more human contact, which causes stress for them because they're not used to being around humans. So something that underlines this hypothesis is that the fecal cortisol metabolite concentrations decreased over time, suggesting the animals got used to all the handling, all the commotion, the movements, and they were less stressed throughout the trial. We also found no significant effect of the fencing system on organic matter digestibility. What we did find was that in vivo organic matter digestibility was higher than the in vitro organic matter digestibility, suggesting that the animals were able to select better feed or the best part of the feed that was available to them. And that's a result of us not restricting feed availability. We had more than enough feed available just because we wanted to focus on the comparison of the virtual fencing and the rotation, and we didn't want to add another stressor of feed restriction. We also found no effect of the fencing on live weight gain. Although there is a bit of a difference between the group, the difference was not significant. So that shows us, all in all, that our hypotheses were wrong, thankfully. We did not find any suggested effect of, or negative effect of virtual fencing on the livestock performance or animal welfare based on the indicators that we measured. And as I mentioned before, with the fecal cortisol metabolites, it would be nice to have more information on longer duration trials to see does the stress reduce in both groups, in both fencing systems equally? Is there a difference between fencing systems over time? And also further analyses regarding effects of animal behavior. Do animals fenced with a virtual fence move differently from animals fenced with a traditional electric wire fence? So don't forget about what I just told you here, because my colleague Dina Hamidi is going to talk more about this animal behavior topic in her second presentation. But yeah, that's it from me for now. So I thank you for your attention.
Thank you, Natasha, for the interesting presentation. I was also interested in finding out like the levels of, is it pinching on the animals? But you explained it, and I'm happy about it. I'm going to take some questions. We've got plenty of time for questions, and there's one over there.
What is the cost per
animal? The no fence system for cattle, the collar is $299 a piece, and you have to pay an annual subscription. That's $52 a year, but it depends on how many months you're grazing, because you're going to pay monthly. So if you graze less than 8 months, you'll pay less than $52.
Also.
No. The vent system works with a tower that communicates with the collar. The no fence system is just the collar and the smartphone app, but it does require the cell connectivity, because the collars, the fence function would stay up, but the collars need to communicate with the back-end database, so you wouldn't receive any notifications if you have no connectivity on the collar.
Okay, I'll take.
I was curious, since you mentioned that the collars that emit the electric pulses are illegal in several countries. In your opinion, how many years of data such as yours that shows it's not harmful to the animal do you think is going to need to happen for those laws to change and allow implementation of a system like this?
If I knew the answer to that, really. I don't know. I hope that there is a study from Ireland that's been going on for 3 years that just published a report that has been able to convince Irish authorities to support the system. So I'm hoping it doesn't take much longer than that. And really I think it just needs some convincing of decision makers, because the reservation towards this electric pulse on the animal is, of course, justified in a way, but the virtual fencing is very different from the dog collars that are illegal, as in the dog collar gives you, as a human, the power to decide when the pulse is emitted. But the virtual fence gives that power to the animal. There's no way, there's safeties built in, and there's no way for a human to trigger that pulse unjustified. So I think to make that vital difference clear is really all that should be needed. But it's good to have data to support that, and just to show that the animals actually benefit from being able to graze. Yeah.
Okay, another question.
I have a question. So with the heifers, is there any concern over like them having heat cycles and that increasing cortisol levels in the people? And how do you take that into account?
This was just a short trial of 8 weeks, and we did continuous animal observations. So in our animal observation data, we would have that information whether an animal would be in estrus and could consider that in the data evaluation as well.
Okay, just one more question. How long did it take for your university's ethical committee to?
How long was it? 2 years?
Long.
Very long.
I can imagine. Okay, thank you so much, Natasha. Okay, we're gonna have 2 presentations from the same speaker. In fact, our next 2 speakers are from the same university as Natasha, the University of Göttingen. But now we're going to have Dina, who's a postdoc. She's going to give us 2 presentations. I'll let her go on. Or yeah, maybe you can stop mid after the first presentation, and we take a round of questions unless they're connected. Okay. So, yeah. Okay. Whose presentation? Is that your presentation? Is that your presentation? Okay. Then hopefully.
Can you right click on that?
You wanna Okay, sorry, she's doing a presentation.
It's my fault, I haven't numbered it.
On PDF, so we're trying to,
Okay.
is this the right one?
No.
Okay. Okay, that's the one.
Right, yes.
Okay.
Thanks. How can I enlarge it? Geht nicht? Okay. Kommst du einmal, Florian?
You won't have it as a...
No, I'm sorry. I work with. I think this one.
No.
No?
That one, the 2 arrows. 2 arrows, 2 arrows.
Yeah?
Double
Yes.
arrow.
This?
Yeah.
Okay. Yes. Applause for Florian Menner, who has solved the problem. And now how it works with this? With this? It works with this? Okay.
Yeah, just...
Okay.
Sorry.
No problem. Okay, thanks for the introduction. Let me shortly introduce myself. I have finished my PhD in the Greengrass project, from which Natasha has told us, and now have started a postdoc position at the University of Göttingen in a project on peatland management, which is an ideal use case for virtual fencing because of the heterogeneity of the environment. But now I talk about results of my PhD or related to my PhD. The presentation is entitled Virtual Fencing Predictable for Cattle. Yes, as Natasha has told us, virtual fencing is in general a simplification of fencing. It is the possibility to managing grazing areas that were previously unmanageable, and to make these fencing techniques which need very much effort, like rotational grazing, holistic grazing management. You can do this with a fingertip, in a way. But a prerequisite is learning to avoid the electric stimuli for the animal by learning that the acoustic signal predicts it. That is really, really important. A period of intentional training is required. And now we make a time. We have to jump ahead in time to the data that Natasha presented, because I'm talking about the initial training period of the heifers. They are the same animal, but we are going ahead in time. And that's, we have the research question: how fast cattle are able to learn to avoid electric pulses when they are naive to the technology and when they have several days of experience with the virtual fence. First of all, you have to know that the no-fence collar provide a teaching mode and an operating mode and an automatic mode change. You don't have to do anything for this, it is integrated in the collar. In teaching mode, it is there to simplify learning for the animal. The animal get the signal, the acoustic signal. It is a melody rising in pitches, and when they just turn around like this, the melody will stop and there is no electric pulse after the melody. In operating mode, they have to go at least 2 meters into the virtual enclosure. As you see in this screenshot from my mobile, this is a blue one there. The animals are all in the virtual enclosure. On the other side, you can see you always know which animal is in teaching mode and which animal is in operating mode. You can see the last animal have this, I've googled the word. It is a mortar. Is it the right word? It wears a mortar. You can see the mortar next to the training period. And the other 3 animals have already changed mode. The automatic mode change gets on when the animal has 19 correct responses to the acoustic signal. That means that there's no falling electric pulse for the animal. We had a 12-day training period. The number of days, because we have already done another experiment with 12 days of training, and that has promising results. It is already published, and so we use the same method again. On day 8, we have done a deactivation of the collars for a short time in the same pasture, so the animals start again in teaching mode. Each time you change a pasture, the animal start again on teaching mode, and here we have done it on the same pasture by deactivation. We have 2 consecutive rounds, day 1 and day 8, for starting new in teaching mode. And these are the 2 groups. These are the 16 virtual fenced heifers, if you remember Natasha's material methods. And they are divided in 2 groups, in each consisting of 8 animals. They had virtual fence on 3 sides. And there where the physical fence is only, there is a gate. This is therefore we use a 4-hour training each day. And after the training, they are going into the stable, into the barn. First of all, I've done a technical validation of the mode change. In round 1 collar changed mode after 34 acoustic signals without falling electric pulses. The other 15 have changed mode in the correct way. In round 2, 3 collars changed mode after 28, 46 and 49 acoustic signals without following pulse. That does not matter for the animal. It is important to know this. It is just more smooth for them when they are already in training mode, but it is important for the evaluation. The results is mode change up, and we haven't excluded these collars from our analysis because we can simulate it. We can say after the 19th correct response, okay, now you are in operating mode. And so you can hear the mode change of all collars, and you see that group was never significant. It is completely irrelevant in which group the animals are. But round is highly significant. Round 1, is the time in minutes that the animal need to change mode, and round 2 is significantly smaller the time they need. Yes, using the integrated mode change appears to be a simple method to test whether and how fast cattle can learn the association between acoustic signal and electric pulse. That is the intention of this. When you are a practical farmer, you don't have the time, and it needs much effort to calculate something like a success ratio or so out of your data. And now you can see it in a simple way. You can see, okay, the animals have changed mode. But to evaluate learning, it is impossible to compare it. Therefore, we use these 2 rounds to evaluate it. But technical problems must be eliminated to ensure a comparable mode change. Cattle are able to predict the electric pulse, which is visible by increased responding to the acoustic signal from round 1 to round 2. But future research is necessary to determine how long an appropriate training period should be. I think this is an important point. These 12 days appears to be a little bit too long in a way. But this depends on my personal opinion on the grazing management you would like to have, whether you want to have something like strip grazing, which is very competitive for the animal. Yes. Thank you for your attention.
Okay, thank you. We can take questions. We've got plenty of time for questions. Okay,
Yes.
I'll take this and then.
I was curious, it's not specifically dictated in your research here, but has there been any noticing of like livestock guardian animals being responsive to the acoustic pulses? For example, like in sheep production, if we were to have a livestock dog with them, would the dog also get a fence collar? Would they potentially be impacted by the sound that the collars make?
Yes.
Curious if you know of additional research that's included guardian animals.
I'm sorry, I can't answer. It's an interesting question, but I can't answer it in a way out of my results. Okay, but if we have plenty of time, I can also provide you another slide of the success ratio. This was the normal way as you measure learning success. The success ratio is acoustic signals without electric pulses divided by the sum of acoustic signals. And here you can see why I think about the training period being perhaps a little bit too long. As you can see, the most significant increase is between the first day and the second day. Okay, any more question?
Yes. There's a question. There's a question at the back. Okay, is it answered? Okay.
I got a question. In your experience, how many collars do you need to control a herd?
This is a very interesting question. I think in cattle it isn't responded as at the moment. I've read about sheep. I think it's a publication of Campbell et al. I think this year, and she talked about 66% of the herd. But you have to take in account that sheep is much more flocked than cattle. I'm not sure. But it's very interesting, and I think especially for practical adaptation, it is necessary to clear this question.
How often do you have to charge those collars or bring them into the barn and
We haven't charged them in this trial, and we have, yes, not really results, but we have tried to leave them a whole grazing period in the last year by a colleague of mine. And we had really unexpected results. We had them from May to October, and I think in September the first collars have problems with the battery life save function. But we don't use the virtual fencing function in this trial. We only use the animal monitoring function, on which I report in the next trial. And I think the virtual fencing, but they have the solar cells on, they are recharging. And I don't know, perhaps Natasha can say something to this. No? Okay. Ah, how nice.
We have plenty of time.
Very nice idea.
I can give you.
The collars come with the solar panels, so they recharge. So the battery lifetime really depends on how small is your pasture, how much do the animals move, how much do you rotate them, assign them to new pastures, how good is your sun exposure, and there's a lot of points, but the goal is for it to last a grazing season to, of course, minimize having to handle the animals.
Thanks a lot. And just to add, we had last year we had animal who said, okay, battery life's over in the night, and at noon the next day they already have again battery life. So it really works.
What percentage of colors drop off?
What percentage of in our trials we had one collar who dropped off in this trial with the 32 animals. In this trial, I just have reported from, no, not in the report, but I have said in this answer, there we have, I think, 5 or 4 for the whole grazing period. But I'm not sure. You just have to ensure that they are really well fitted with this. And I think we had this young beef cattle. I think perhaps dairy cattle, which you handle every day, then you can ensure that it is right, and that makes it a little bit more simple, I think.
Okay, I have a question. Would you say the system is more, or the use of these type of collars is more relevant in a more controlled system? I'm asking because, as you may have had, I work in communal rangelands where there's no control over where the animals go.
I think there are many cases you can use it, and I think for communal grazing it is very, very interesting because you can identify the animal via the collar. I'm not experienced with communal grazing, but I think this is an interesting point, and you can make the borders, the boundaries, like you want for the animal of some owner. But you need research.
Okay, thank you. There's another question.
If the collar knows where the animal is, do you know where the collar is if it falls off the animal?
Yes, of course. Perhaps this answer I will answer on the next, this question I will answer in the next. But interesting questions, very nice.
Okay, I will let you go on with your second presentation. You need help?
I need help, yes. I always need help. Thanks a lot. We will ask Florian one time if we can't do it. Yes, now. Moment power. Okay. Okay, now again, you need a lot of flexibility. The audience is very tough, and you have to jump again. Not ahead in time, you have to jump back in time. Now, this data is from the trial Natasha reported, and it is about animal monitoring using the virtual fencing collars. It is entitled, More Than a Fencing System, Testing the Validity of Virtual Fencing Collars for Animal Monitoring on Pasture. Yes, virtual fencing collars simplifies fencing, as you all know. But there are difficulties for animal monitoring on pasture, especially continuous animal monitoring. this is provided in barns at the moment, but on pasture, especially in pastures, they are not nearby the farm or something like this. There could be health problems or some other issues, you know it better than me perhaps, and you need something to continuously monitor it, to see health problems in an early stage. Conventional GPS collars are commonly used to monitor walking distances and the distribution of animals on pasture. And commercially available tracking systems are often too expensive for practical use. That is really an issue. Therefore, we have the research question, how and whether is it possible to use the real-time GPS data collected by the virtual fencing collar to improve animal monitoring on pasture? You can see in this picture in former times it wasn't such a problem because you have the herdsman and he is watching the herd the whole time. But now, indeed, in practical use it is you have the animal on the pasture. I don't know how it is in other countries. In Germany you have the duty to ensure animal welfare once a day. But you don't, what about the other time? You don't know what is about the other time. It is a black hole, and perhaps the animal is standing when you look around the pasture, and the next half an hour it is lying down and yes, just dying or something like this. Okay. Yes, again to the collar. Perhaps you can give it to me so I can. Thanks. Okay, we have talked about the solar cells. We also have Bluetooth. This is very interesting for the communal use, yes, because each animal you can locate with a Bluetooth function from your mobile, and it plays a melody, and you know, okay, this is my animal. They are all looking the same, but this one is mine. Then it has this rechargeable battery, and it has a motion sensor. This registers acceleration along through 3 axes. And this motion sensor has also a battery life save function. And this is the question I answer from you. This battery life save function, if the collar is on the neck of the animal, everything's fine, the animal will move and there is motion all the way. But then the collar is dropped down and it is lying there. And now the battery life save function. No, there is no motion, and sends the GPS position, the same GPS position, over the whole time. This helps to save battery when the animal is just lying, because when it is lying you don't have to virtual fence it because it is stationary on the place. And when the collar is lost, it helps to detect the collar. Yes, it consisted also of a GPS receiver, but Natasha has said it all, and the communication is over a mobile network with a no-fence app, but this is also told by her. Yes, just to remember, that is the material and matters. We have a rotational grazing with virtual fencing trial in 2021. It was 32 heifers in two groups. It is virtual versus physical fence. We had 2 grazing periods. The results are reported are the last grazing period, the second. We had 8 animals in a 2-hectare pasture subdivided into 4 paddocks for 3 to 4 days of grazing, then rotation. Animals were equipped with sensors, the no-fence virtual fencing collar for GPS positions, activity signals, and the cow manager animal monitoring, animal behavior tracking, and ice tag pedometers for step count, lying and standing time, and this is really important for my talk, animal observations, 2 hours per group and day. These animal observations were performed from Natasha and me, you recognize us, and on 6 of 15 experimental days of rotation, approximately 2 hours, and 1 observer per group. We had 4 animals per group that were observed, not the full 8, because it is very difficult to continue. If anyone in the room has already tried it, it is difficult to focus on 8 animals on the same time, and so we choose 4 out of 8. And we continuously observe their behavior via an app. And then we perform a validation. A validation is necessary because we want to use the battery life save function to get the lying behavior. As you all know, the most common behaviors on pasture for cattle is lying and grazing. And if it is possible to divide these both with GPS collars, which is a problem with commonly known GPS collars, then you can get a relationship between the grass, between the forest. You can see the pasture utilization in a way. And therefore, we want to validate the lying behavior. And we use this battery life save function because the accelerometer of the collar, yes, it needs more energy than the collar can provide at the moment. When you also use the virtual fence function, which is the main thing of the collar, you don't have enough energy for this. And therefore, we make a two-step validation. In the validation step 1, the actual data was the observational data, and the predicted data was the ice tag data. The validation step 2 was the actual data was the ice tag data, and the predicted data was the VF collar data for lying time. We've done the validation with a confusion matrix, which is quite a common thing for this kind of validations, and use the quality measures accuracy, precision, and recall to prove the reliability of the lying detection. And the results of the validation step 1, we used in total 4,649 data points, and each point referred to 1 minute. The precision is 98%, the accuracy 97%, and the recall 92%. This isn't quite surprising. Ice tag accelerometers are known to prove reliable on detecting lying time. But now we have the validation step 2. There we have in total 195,355 data points, and there we have also a high precision with 93%, an accuracy of 89%, and a recall of 83%. And therefore, we see that they prove reliable. The full potential of the accelerometer for evaluating different behaviors cannot be used so far, as I've already said, due to high energy costs for data export, as it was also described by Ryabov et al. But there is already a first study that investigated the possibilities of the integrated accelerometer by using 48-hour bouts to classify a range of behavior, and even rare behavior was good classified. And this is really interesting because it is expected that these energy problems will be solved in problem. When you remember 20 years ago how long your mobile has energy, and you see now, I think there is a progress. However, our approach to use the battery life save function, which sends the same GPS position during low movement to detect lying behavior, appears to be an additional aspect to the known features of GPS tracking, such as detecting walking distances and animal location. Based on our convincing results, VF could be more than a fencing system. Virtual fencing not only facilitates fencing, but also offers the possibility of continuous animal monitoring via the real-time GPS data. Energy efficiency is expected to improve further so that the full potential of the integrated accelerometer can eventually be utilized in future. This is also interesting as, for example, the British Animal Welfare Committee said double-collared animal should be avoided. And so we can, and also in practical use, there's always a question, how much does a collar cost? Yes, how much does it cost? That is a question. In research, it is not so a question, but in practical use, it is a question. And so it is very interesting to use one collar for a range of possibilities. And there are even more. We have, just to give a little outlook, we have linked this data to remote sensing data to evaluate pasture utilization with very promising results. Yes, thank you for your attention.
Okay, thank you, Dina, so much for those two interesting presentations. I will take questions for the second presentation. Yes.
Did you have an idea of why in the
validation step, for example, you recall data
Yes.
went down to 80-something%.
Yes.
Why is it going low, or is it not higher in the
Uh,
validation step?
Yes, you really know the things. Yes, it is. It is because the motion sensor needs some time to react, and so it is later on. Normally, GPS collars have the problem to provide more lying time, as they also detect standing as lying. There's a probability, and with this collar, it is different another way. It needs some time to say, okay, motion sensor says there's no motion, and then it reacts. So it is an underestimated, and it's a bit underestimated lying time. That's the answer, yes.
Another question? No more questions? Oh, there's one more. Yes.
Collar measure elevation.
Elevation? Good. No. No.
It should,
It should. Why?
because when they're lying down, they're at a different elevation.
I'm sorry?
Ah, that's right. Get the military version, it'll do it.
Ich habe ihn nicht verstanden. Was sagt er? Ja, aber warum? Ah, okay. Aber das stimmt gar nicht. Die Accelerometer würde es mitgeben. Der hat ja 3 Achsen. The accelerometer will provide it. I'm sorry, I haven't really understand the question, but the accelerometer will provide this. I think that is also a problem that will be solved with more energy efficiency. Yes.
Any more questions? Okay, thank you so much, Dina. Okay, our next presenter is it Juliana. I wanted to say Julian. She said it's Juliana. And she's also from the University of Göttingen. And she is also postdoc. And she will give a presentation on herding livestock. The phoenix rises from the ashes. Digital herding as a future tool for grazing livestock.
Yes, thank you for the kind introduction. My name is Juliane Horn, and I'm also involved in the project GreenQuest, and I have the honor to close our German GreenQuest group round with a review about digital herding technologies. Yeah, grazing has been declined at the global scale since 2000, and the pasture area since this time frame is equivalent to the country size of Peru. Sustainable grazing that balances selective feeding behavior, trampling and seed dispersal is highly important for biodiversity and ecosystem services. Oh, no, that's wrong. Okay. Blah, it's a bit complicated. Yes, therefore, sustainable grazing requires a sound understanding of the animal-sward interaction and a fine-tuned adjustment by stocking methods that balances the livestock feeding demand with the herbage availability on the sward. Traditionally, livestock has been shifted around a farm or kept within a boundary using green fences, walls, electric fences, gates, or even human herders or herding dogs. Fine-tuned grazing is challenging by current methods and tools as labor time and costs for management and material are high. Yeah, current developments in digital herding technologies are promising for flexible, sustainable, and efficient grazing. And thus we did a literature research for the latest studies on digital herding technology, such as virtual fences, drone, and also robots for managing and controlling cattle, sheep, or goats within grazing sites, and also target herding of these animals across grazing sites. And today I want to highlight the most recent findings and challenges for virtual fencing and also drones. In general, digital herding technologies are supposed to provide a high level of precision in the spatial and temporal stocking, and also to give the chance to develop innovative and novel grazing systems. Supposed advantages of digital herding technologies are the flexibility in the stocking method management, the opportunity to implement grazing in formerly abandoned grazing systems or even protected habitats where fencing is prohibited, and also the implementation of important rest periods for natural vegetation to recover. Another advantage should be the optimization of pest utilization, the reduction in the labor input, and also the enhancement of animal welfare monitoring. Yes, the one key technology of digital herding is virtual fencing, and virtual fencing allows a fine-tuned adjustment of the accessibility of certain pasture areas at certain times for the grazing animals. Informations on virtual fences set on the farmland are transferred to the animals through a collar, and this collar combines GPS with a pre-warning sound and an electric pulse to prevent the animal to crossing the virtual border. Yeah, the development of virtual fencing dates back about 50 years ago and had its origin in the USA. And now there are 4 companies worldwide which develop automated virtual fencing systems from Australia, the USA, from Europe, and also New Zealand. Especially the virtual fencing systems, eShepherd, NoFence, and Vance have been intensively tested and also have been improved in the last years. Cattle is the most studied livestock, followed by sheep, and a few studies for goats exist. Most studied cattle breeds are Angus, which is often used for beef production on extensive sites, followed by the high-performing dairy breed Holstein and also the robust dairy breed Jersey. Heifers are mainly used in virtual fencing studies. Steers and cows are rarely tested. Testing a wide range of different animal breeds and growth stages is highly important to determine the learnability, the effectiveness, and animal welfare of digital herding technologies. As you can see on the table on the left, the main focus of virtual fencing studies so far are on animal learning, animal behavior, and the effectiveness in confinement mainly for continuous stocking with one single virtual fence line. There are few studies on animal welfare in terms of stress indicators. There are very few studies on agronomics. There are 1 or 2 studies on rotational stocking and environmental protection. group dynamics in learning and the applicability of virtual fencing for herding and splitting livestock and nature conservation tasks are very rarely studied. Yeah, studies on animal learning of virtual fencing indicates that the initial learning time is after 2 up to 8 fence interactions or within 48 hours. Over time, there is a significant reduction in the electric audio-GU ratio. That indicates successful learning. First studies on moving virtual fences every 2 up to 4 days, as in rotational stalking, showed no impacts on the number of stimuli delivered to the animals. There is individual variation in the number of audio warnings and electric GUs among individuals. For example, there are 2 or 3 cows per herd in general that graze closer to the virtual fence line, receive most of the audio GUs and often really test the fence line. But there's a lack in the research on their impact in the social facilitation in learning of other group members. Also, the duration of memory and retraining efforts are not known yet. Studies on animal learning for more advanced grazing methods like strip grazing are also missing so far. Animal welfare is important consideration for the commercial implementation of herding technologies, as typical welfare indicators for cattle behavior patterns, stress hormone concentrations paired with livestock performance are often investigated. Deviations from normal patterns can indicate discomfort or even stress. There are only few studies that directly compared animal welfare between virtual and physical fencing. These studies indicated no higher stress hormone concentrations for virtually fenced cattle compared to physically fenced cattle. Also, virtual fencing led to minor or no difference in cattle behavior and no negative effects on live weight gain or milk yield. However, more studies are necessary to confirm not any negative impact on animal welfare for sure, and this includes research on rotational and also strip grazing and also further breeds, because Angus is the mainly breed studied. Yes, virtual fencing was demonstrated to successfully contain grazing livestock within the desired grazing areas. Up to about 99% efficiency has been demonstrated for different virtual fencing systems, but mainly for continuous grazing. So virtual fencing was also suitable for exclosure from cattle from environmentally sensitive areas, and only one study measured the damage of protected plant species within a small-sized exclosure and found no trembling or feeding damages on those plant species. There's only one study that demonstrated the successful direction of animals to new pastures and herd splitting by setting up and moving virtual front and back fences. However, efficiency for completely fenceless rotational or strip grazing paddocks has not been investigated so far. Also, research efforts for smart-sized and temporary virtual exclosures for protected plant species or also bird nesting sites are not there so far. And also, more research is needed on methods for successful herding and gathering and splitting captive groups with front and back fences. Yes, regarding livestock management with drones, much research on technical solutions for detecting, counting, tracking and monitoring livestock has been already started. For herding cattle and sheep with drones, only a few studies exist. These include the efforts on the optimal flight trajectory for livestock to drive cattle to a desired location by the different positioning schemes of multiple drones. One study investigated the stress response of cattle to flying drones and found no negative effects of the flying drone on the herd rate and the movement rate. Another study tested the response of a flock of sheep to the presence of a flying drone, and sheep spent more time moving around in the presence of the flying drone, whereas sheep spent more time with grazing in the presence of the human or also a dog herder. So this implies that a stepwise habituation to drones is a precondition for herd management. For broad application of drones in livestock management, some challenges regarding the operational issues and data analysis for more automated herding needs to be solved, and also the economics for data analysis and also the labor time for flying the drones need to be estimated. Research efforts on livestock behavior and welfare in response to the flight height, to the speed, and also to the approach angle are required. Yeah, to conclude, livestock herding technologies open up new opportunities for grazing management. Yeah, I get it. And paradigm changes in grazing management. They open up also new dimensions for animal monitoring, but some challenges need to be solved yet. These include the technical improvements and also the assessment of the economics and operational preconditions for on-farm application. Also, the economic and ecological benefits need to be assessed for diverse grazing systems. In the end, the improvement by the technologies depends on a sound understanding by the farmer how the technology works, its technical limitations, and how to respond in the event of any problems. So farmers need to be tech savvy and also trained to gain real advantages from digital herding technologies. Thanks for your attention.
Okay, thank you, Yoyan. Now we don't have time for questions. We're just going to move on to the next speaker, which is Connor Halihan. Thank you. This is your son. Okay, Connor will present an assessment of young cattle behavior and welfare in a visual fencing system.
Thank you. Hello, everyone. Okay. So my name is Connor Houlihan. I am a grassland livestock scientist based at the Agri-Food and Bioscience Institute in Northern Ireland. And we have been running a virtual fencing program for the last number of years. And today I'm going to present on one of our studies that looked at animal welfare. So this was an assessment of young cattle behavior and welfare in a virtual fencing system. So just to give you a bit of background, I'm going to whiz through this fairly quickly because our good friends from Germany here have give us some background in terms of how the system works and what it is exactly. But virtual fencing, so we're all aware of the traditional fencing methods. Some of you maybe aren't too familiar with some of the stone walls that we would have back in Ireland, but so essentially what virtual fencing is it's fencing of livestock without a physical barrier. How it works then, so as Natasha outlined earlier on, there's two key components to the system, so the GPS collar and then the mobile phone app, so the two of them work with each other then, so I'll explain that in a little bit more detail. Training typically takes place over a 1 to 2 week period, so we give the animals a single virtual fence line, so this is just what the diagram here in the bottom is showing, so we give them one virtual fence line during that period and we allow the animals then to interact and learn the correct audio or learn the correct responses to the audio cues and to the pulses. So when training's complete, then this is just a couple of screenshots from the app with the no fence system. So whenever training's complete, we can mark out where on the farm we want to keep the animals. So this is just the grazing platform at Hillsborough at our main research station. We then select which animals in the herd we want to enter in that area, and then we just confirm then to set that pasture. So when those animals leave the yard, they will enter into that virtually fenced area, and then the system will start then once they've entered inside. There's other information we can get as well in terms of tracking of the animals, the number of audio cues, the number of pulses that they receive daily. So we can look at individual level and at the herd level or the flock level as well. There's a number of applications, as have been pointed out, for virtual fencing. So in an intensive lowland type grazing system, we see there being scope there to use virtual fencing as a replacement for electric fences. So where you have an existing paddock system in place, but you may use it then to forward graze or front and back fence your grazing animals. And then there's also the extensive side, so extensive grazing systems, so the mountains and uplands in particular, where we've large swathes of land, often impractical to fence off those areas. So with virtual fencing, it gives us the opportunity then to fence off these areas and also to fence animals within. So if we have things like bog holes or swamps and things like that in those environments, we're able to exclude the animals from those. Benefits then, so there's three key areas really around the benefits. So for the farmer, it gives improved management and monitoring. There's opportunities there for the environment to protect sensitive habitats in particular, and for the livestock themselves, so where we have increased monitoring of these animals, there's potential there to increase or to improve their safety and their welfare. So our research program at AFBI then, as I mentioned, we're just starting year 3 now of that study. So we've commenced, or we will be commencing grazing with the virtual fences this week. There's three main areas that we're looking at with this research. So functionality, first and foremost, that's just the basics. How does it work? How reliable is the technology? The animal impact, which all eyes are on really. So what impact this technology has on the learning, the welfare of these animals, their behaviour, and also in terms of their productivity as well. Are there any negative consequences with that? And the third one then is looking at the capabilities of this system. So are there things that virtual fencing may allow us to do that conventional fencing doesn't? And also looking at the limitations of the system. So how far can we push this before there is maybe some detrimental effects on the welfare? So we've looked at a number of different aspects, so different livestock classes, different ages, different species, sheep, beef cattle, dairy cattle. But this particular study that I'm just going to present today then is on young stock. So this was a study we done in 2021. Just some of the materials methods then, an overview of what we done. So we had 2 treatment groups. We had virtual fencing and electric fencing. And we had 4 groups of 8 calves in each of those treatments. So 64 in total. It was conducted over 2 separate cohorts. Each lasted a 32-day period. All the animals that we used in the study were naive to both virtual and electric, so they'd never experienced either. And then they were balanced then on age, weight, gender and breed. Key measurements we looked at then were cortisol. So as the guys mentioned here earlier on, fecal cortisol metabolites being the main metric that we use for stress level assessment in these virtual fencing studies. We looked at activity through the ice tag accelerometer system. Behavioural, we took behavioural recordings, so video recordings for the first number of days of the study to see how the animals impacted or how they reacted to receiving the virtual fence pulse, and live weight gain then as well. So how we set it up, so this is just one cohort, so we had 2 groups of each treatment. So we gave them 10 days training period at the start, so we implemented our first virtual and first electric fence lines. And the idea was then, as the experiment progressed, we wanted to make it more difficult for the animals, to try and push the limits of the system. So after the training period then, in week 1, we gave them a 3-sided virtual fence, 3-sided electric fenced area. We then moved them then for the 3rd week, and then for the final week of the study then we put them into a fully enclosed virtual area. So some of the results then, so this picture just shows you the mobile crush we had to use. Obviously these animals were out in the field, so instead of bringing them in and causing extra stress, we actually just used this system where we weighed them in the field. So in terms of body weight then, we see no difference between electric or virtually fenced animals in their body weight or their daily live weight gain. Looking at the behavioural recordings then, so we sat down and went through these and looked to really see what happens when the animals do get a pulse in both systems. So we see no extreme reactions to either. So similar responses to the virtual and the electric fence pulse. Grazing resumption in the electric fenced calves was marginally slower, so they were slower to resume grazing after they had received the pulse. And then the accelerometer data, so from the ice tags, then we were able to look at the standing time, lying time, and the step counts of each of those animals. And we could see as well here that there's no difference between the electric and the virtual fenced animals on that front. Fecal cortisol then, as I mentioned, so that was another big metric to see the stress levels of these animals. So the mean cortisol, again, there was no significant difference between the virtual and the electrically fenced animals. And I'll go into a little bit more detail about this, on an individual level, how that panned out. But looking then at, so this graph shows us the pulses as a proportion of audio cues. So what we're looking at here basically is the percentage of times that the animals came in contact with the virtual fence that resulted in a pulse. So from day 1 to day 33 of the study, and at the start, so around about 20% of interactions resulted in a pulse, and then over time, then that dropped down. So you can see our training phase was days 1 to 10 here. So the rate of pulses dropped up until around then, and then we moved them into their 3-sided virtual fenced area, and that's where we see that spike in the pulse rate there. So then this was kind of really, we wanted to dig down a little bit deeper and look at the individual animals themselves and what impact that is having. So it's fine to look on a group level, but it's important then that we look at individual animals and see what's happening there. So with this graph, each of these bars then is an individual animal. So the 32 animals that we had on the virtual fence. This is our stimuli count. So in the blue, we have the audio cues, and in the red, here we have the number of pulses. So this graph is ordered from low to high in pulses. So that ranged from 7 to about 70, 72 actually, in fact, was the highest number of pulses received. So on average across the 32 days, they received 31 pulses on average across all the groups. But what we're seeing is, so essentially there's huge variation between these animals. So having a high number of audio cues isn't necessarily translating to a high number of pulses. So we're seeing individual variations in their behaviours and how they're interacting with the fence. So the question then really is, do more pulses mean higher stress? And what we've seen, just looking from some of these correlations, is that they're not strongly correlated, the two. So essentially, if an animal is getting a high number of pulses, their cortisol levels aren't accordingly, or they're not at a similar high rate as such. So some animals had lots and lots of pulses and a low number, or a low cortisol percentage in the feces, and vice versa. So really what that's telling us then is that different animals react differently, and there's a difference in how uncomfortable that the pulse makes each of those animals feel. So the resulting level of cortisol, or the injection of cortisol into the system, is variable really. So that's all, folks. And just to conclude then, so the technology functioned correctly. It was able to keep these animals within the virtual boundary. Our results so far indicate that there's no negative impact of virtual fencing in these types of young stock. We should consider going forward that there are individual variations and differences between the learning and behaviour, and we need to account for that, particularly when we're training these animals, that some might be slower and some might be faster to learn than others. So that's all. Thank you very much, folks.
Thank you, Connor. We've got a few minutes to take a round of questions. Yes.
Did you look at, or do you know of any studies that have been done to show a difference in individual responses of animals based on their background? So whether they've been raised on that farm in that situation, or whether they come from a totally different background, and who knows what their situation was prior to where you are there?
I'm not aware of any studies that have looked at that specifically. What we would have done is took base level measurements of cortisol, and then we balanced the groups accordingly. So all the animals were reared on the farm. These were dairy cross calves. So yeah, it's something we probably could look at a bit further. In some of the other behavioural work that we're doing this year in particular, we're looking at behavioural tests and using those as well to balance out the groups, just to try and minimise any sort of prior life experiences of those animals on the study results.
Okay, so another question. I'll take it.
You may have said, what was the age of the calves, and then what would be the youngest dairy calf that we would want to pull a detector into?
So these calves were in around about 6 months of age. So they were weaned calves that stage. In terms of how young you could go with them, maybe Natasha, I might turn to you here to ask. So in terms of an age, is there a limit of how young the animals can be when you're introducing them to virtual fencing?
Yeah, the Animal Welfare Council, the UK Animal Welfare Council gave recommendations. I think it's 4 months for calves and 6 for kids and lambs. It really depends. There is a recommendation as to how much percentage of their own body weight they should be wearing around the neck, and that's really the main restriction. For the farmers that are using no fence right now, they usually start putting on the collars when the animals start moving too far from their moms, and the moms get too nervous with the animals. So that's about that range.
Thank you, Natasha.
For that particular study, we actually had to adapt sheep collars, just based on the weight of the collar. We couldn't put the cattle ones on there, just a little bit on the heavy side.
Okay, is there a question? Yeah, first.
I wanted to ask about 32 shots at the high end. Was there any performance issues? I mean, that seems a lot of shots. I know you're pushing the density, but was there any negative on that?
Well, the main metric we looked at was the body weight, the daily live weight gain, and we see no differences there between the groups. Between individual animals, we haven't actually looked at that yet. That's something we do need to explore a little bit further. But on a group level, we didn't see any differences there.
Okay.
When you rotated them to a new pattern, how long did it take them to find that boundary?
Relatively quickly. The animal's behaviour changes slightly, so they become more inquisitive, and they tend to potter around and try and find where that new boundary is. So they will figure it out within 10 or 15 minutes of moving the virtual fence, that there's no fence there anymore. And it's not a case that they go running. They sort of gradually move around the grazing area till they hear that audio cue, and they become accustomed to where that is then. So it's relatively quick, yeah.
Okay, I'll take one question, and then we're out of time. Yes.
I might have missed this, but can you just comment on the level of control? Did you have at any time animals move outside either the virtual fence or even the electric fence?
Did they break out?
Did you have any, in all of those, did you have any breakouts?
Not in this particular study, no, we didn't have any breakouts through the virtual or the electric.
Okay, thank you. Sean Connor will be available after the session to answer any more questions. Thank you so much.
Thank you, guys.
We'll move on to the next speaker. Okay, our next speaker is Jipeng Liu, and he will be presenting on analysis of drought tolerance traits and molecular breeding in alfalfa. Thank you.
Good morning, everyone. Today, my talk is analysis drought tolerance traits and molecular breeding in alfalfa. I came from Lanzhou University, China. This is my email address, cell phone number, and WeChat code. Firstly, the background. In China, about 17% of alfalfa is planted in the drought area. This is a map of China. In this color, alfalfa is planted, and also in American, about 20 to 40% of alfalfa is sweated by drought. Totally, the drought stress can reduce the yield by 50%. Although alfalfa has a very, very deep root, however, the deep root can tolerate short-term drought, but can't tolerate long-term drought. So in China, we can see in the right finger, the alfalfa is irrigated in China. This is a very big area in the Mongolia province. So as we all know, the drought tolerance is a very complex character. So if you want to use the molecular method to speed up the breeding program, it's very difficult because alfalfa is a long model plant. If in a model plant such as soybean, maize, and rice, it's easy. In the non-model plant, it's very difficult. However, there is an example in the chickpea. This work is done by an Indian scientist. He used the QTL to find a molecular marker which is linked to the drought tolerance, and also the water use efficiency, seed and above ground biomass. So I think if we do same work in alfalfa, we would success. So secondly, I wanted to introduce some drought tolerance trait analysis in our lab. In the past 3 years, there are big progress in alfalfa and alfalfa relatives genome sequence. Some Chinese scientists and American scientists published many articles about of the genome. So based on this background, we did in our lab we carried out many RNA sequence work, such as we used the malantol, EBA, and other chemical to mimic the environmental stresses. We published some articles in the transcriptome field. And then we use the transcriptome method. We found many genes that involves in the drought tolerance. However, how to use these results is very difficult. So we analyze some gene families, and we wanted to find which number is more contribute more. Furthermore, we are estimate the world first website. In this website, the website includes not only the data from my lab and also from other lab. The data include the transcriptome data and also 4 genomes of alfalfa and the relatives, and also some protein results and the resequence data of alfalfa. This is a website of the alfalfa. You can visit now. After that, we got many genes that may be contributed to the drought tolerance of alfalfa. So we use the genetic method to transform maybe 20 genes to alfalfa. This is one example. From this picture, we can show in the left is in the same pot, the wild type and the overexpression transgenic alfalfa planted together. From after stop irrigation for 39 days, we can see the overexpression plant performance better than the right type. In this picture, you can see if we also plant wild type and iron interfering to lock down plants in the same pot. From this experiment, we can find the wild type performance better than the iron interfering plant. So we think this gene, MSNTF2L, is positive, regulates the drought tolerance of alfalfa. So we also did other work like such as RNA sequence of wild type, overexpression type, and lockdown type. And finally, we got the models that contains the molecular level and physiology level to explain how these genes regulate the drought tolerance in alfalfa. This work is done by my postdoctor. He also found another 2 genes. It's different from these genes. This is the first, second, and the third genes are also involved in drought tolerance. So the last part, I wanted to introduce the drought resistant breeding in our lab. Maybe 10 years ago, I started to do the RNA sequence of alfalfa. And 4 years ago, in our lab, we started use other methods such as GWAS analysis. This means genome-wide analysis of study. And in this part, we use the natural populations. This population includes 258 alfalfa accessions. In each accession, we use the one individual plant, and also we cut in more than 1,000 plants. This experiment is done in the greenhouse. We use the four characters to describe the drought performance of different alfalfa. Furthermore, we use the same population. We did some field experiment. This is in field. We used in two. This work is done in the last year. That this is 2021. In each year, we have irrigate and not irrigate field. So after the resequence work and the caricature about related to the drought, based on this, we found some genes that may be involved in drought tolerance of alfalfa. This is a different genotype of alfalfa. The drought tolerance is different. And also we construct a population with the parents are Medicago sativa subspecies sativa and Medicago sativa subspecies furcata. The F1 generation contains 310 hybrids. And we also resequence the parents and the hybrids. This work is done in the Inner Mongolia and Inner Mongolia province and the Gansu province for at least 2 years. We measured many characters. This is one character is canopy temperature of different hybrids. Different color means different tolerance to the drought. And then we construct a high density genetic map of alfalfa. Use this map, we got some genes that are involved in the drought tolerance. For example, this is the result in the last year. It's in the Gansu province. This picture is in the Inner Mongolia province. So we got the same for QTL that is related to the drought tolerance. Furthermore, we used our result of transcriptome sequence and QTL and GWAS and some screen in the field to find some drought tolerance individuals. We did some molecular breeding work, and we this population we can see in the different year the yield of our new material is higher than the control. Summary: in our lab we use the transcriptome GWAS, QTL, and a bunch of drought tolerance genes are found and identified in alfalfa. Secondly, the compatibility of the drought tolerance with yield and the quality should be consideration. For example, we found another genes that also positive regulators the drought tolerance in alfalfa. However, if we overexpress this gene, the genes, the drought tolerance is improved. However, the yield and the quality is reduced. So certainly, how to use the genomic selection or the molecular design method to improve the complex characters in alfalfa, such as drought tolerance, is a very big question. We just start. Thanks for the National Natural Science Foundation of China and the National Keen Research and Development Program in China. Finally, thanks and welcome all of you to visit Lanzhou University in the future, and the faculty and the postdoc position is available always. Thank you.
Thank you, Zhipeng. We have time for maybe 1 or 2 questions. I'll take.
Yes, I was wondering if there was any relationship between your molecular genes that you found in the pathway and what you were finding in your GWAS.
Yes, it's a very good question. We found many genes in GWAS, and also we got the gene expression panel in the RNA sequence. Some genes the expression panel is, we hope is not, some is not. But we think if we use the RNA-seq and the GWAS and the QTL, if we use these 3 methods, is maybe to combine this result of 3 methods, we will find more useful genes.
Just one more? Okay.
Can you show slide 18 again? There was QTL analysis for 2 locations, right? So there's
Yeah.
difference between, there's quite an environmental interaction with QTLs that you find.
Yes. I think the drought tolerance is very complex. So we measured a lot of characters, different characters in different year, in different locus. The result is quite different.
Okay. Thank you so much. Thank you, everyone, and thank you to our presenters. It's the end of our session.